We know that the potentiometer, it is an ideal voltmeter, and it is a device which is useful for to measure the potential difference. Previous lecture we already studied about the principle of only statement, the principle of potentiometer. I repeat once again that principle. The potential difference between any 2 points, potential difference between any 2 points on potentiometer wire is directly proportional to the distance between that 2 points on potentiometer wire. The potential difference between any 2 points on potentiometer wire is directly proportional to the distance between that 2 points on potentiometer wire. Today our aim is to explain that principle. For that purpose, I have drawn here the circuit diagram. In this circuit diagram, it consists of a thin long uniform wire which is fixed in between 2 points capital A and capital B on a wooden board. This is the thin uniform wire. It is fixed in between 2 points A and B on a wooden board. A battery of EMF E plug K, they are connected in series across this wire AB. Let capital L be the length of this wire AB. Capital L be the length of this wire AB. Capital R be the resistance of this wire AB. On that wire, let us consider a point P, which is situated at a distance small l from point A. Means small l is the distance between point A and point P on potentiometer wire. VAB means potential difference across wire AB. VAB, it is the potential difference across wire AB. Let us see, these are the some points related to principle of potentiometer. Here sigma, resistance per net length. Sigma is equal to total resistance of the wire divided by total length of the wire. Let I be the current flowing through the wire. VAB, potential difference between the points capital A and capital B. VAB, it is the potential difference between the point A and B. VAB, that is the potential difference across wire AB, is equal to the current flowing through that wire into the resistance of that wire. VAB is equals to IR. VAB is equals to I sigma L. See this formula, sigma is equal to resistance per net length. Therefore, from this formula I am able to write that capital R is equals to sigma into L. हा जो L इकडे डिवाइड आहे, इकडे जाऊन LHSला केला ना तो मल्टिप्लाय होईल. Capital R is equals to sigma into L. Therefore, from this formula we are able to write that capital R is equals to sigma into L. That is the potential difference across wire AB is equal to current into sigma into L. Sigma into L is nothing but the resistance of wire AB. From this formula I am able to write that current is equal to potential difference across the wire AB divided by sigma into L. Capital I is equal to VAB divided by sigma into capital L. This is the equation number 1. Now, let P be the any point on that potentiometer wire. The distance between point A and point P, it is denoted by small l. Therefore, the potential difference across the point A and point P on potentiometer wire is equal to current into the resistance small r, resistance of that wire AP. Here small r is the resistance of wire AP. From this equation I am able to write that the potential difference across the 2 points A and P is equals to VAB divided by sigma into capital L, and for small r it is equal to sigma into small l. Sigma is the resistance per net length into multiply by length. It gives the resistance of wire AP, because here small l is the length of wire AP. सिग्माला जर स्मॉल एलने मल्टिप्लाय केलं तर डेफिनेटली वायर ए पीचा आपल्याला रेजिस्टन्स मिळेल, कारण स्मॉल एल ही जी लेंथ आहे ती वायर ए पीची आहे. करंटची जी करंटसाठी जो फॉर्म्युला लावतो तो इथे पुटअप केला आहे. व्ही ए पी ॲज इट इज करंटसाठी व्ही ए बी डिवायडेड बाय सिग्मा एल, स्मॉल आर इज रिप्लेस्ड बाय सिग्मा इंटू स्मॉल एल. दिस sigma get cancelled, therefore the remaining terms VAP is equals to VAB divided by capital L into small l, when as the total length of the wire AB is constant, therefore the potential difference across the wire AB remains constant. These are the constant terms, therefore constants and equal to sign get converted into proportionality sign. Therefore that above equation becomes VAP is directly proportional to small l, and this is the principle of potentiometer. The potential difference across any 2 points on potentiometer wire is directly proportional to the length or distance between that 2 points. This is the principle of potentiometer. The principle of potentiometer. Potential difference between any 2 points on the potentiometer wire is directly proportional to the distance between that 2 points. That is, VAP is directly proportional to LAP. Here, VAP, it is the potential difference across the point A and point P on potentiometer wire, and LAP is the distance between point A and point P. Now our aim is to study about the use of potentiometer to compare the EMF of two cells. Now our aim is to study about the use of potentiometer to compare the EMF of two cells by separate cell method. Another name of separate cell method is a individual method. This is the circuit diagram useful for to explain the use of potentiometer by separate cell method. This potentiometer, it consists of a thin long uniform wire AB. It consists of thin long uniform wire AB having length 4 meter. It is fixed in between 2 points A and B on a wooden board. A driver cell of EMP, plug K, rheostat RH, they are connected in series across the point A and B. The positive terminals of cell E1 and cell E2, whose EMF is to be compared, they are connected to point A. The positive terminals of E1 and E2, they are connected to point A, and negative terminals, they are connected to jockey through two-way key as well as galvanometer. This is the part of construction. This is the circuit diagram which is useful for to give the explanation of potentiometer for to compare the EMF of two cells by separate cell method. Let us see the some points related to construction. These are the 3 points related to construction. Now let us see the working. First of all, close the plug key K as well as K1. Here K2 is open. Because of that, only this first one cell is in this circuit. Then after you start to touch the jockey on potentiometer wire at various points, and you obtain the point P at which galvanometer shows zero deflection. By touching the jockey on potentiometer wire, obtain the point P at which galvanometer shows zero deflection. When the galvanometer shows zero deflection, you measure the distance between point A and point P. Suppose it is L1. Therefore, I am able to write that. These are the some points related to working. Now here we have already measured the distance between A and P, it is L1. Let the length between A and P, it is L1, I be the current flowing through the wire, sigma be the resistance per net length. The EMF of cell E1 is equals to I into sigma L1. Sigma is the resistance per net length. Whenever that sigma is multiplied by L1, we got the resistance of that wire L1. Means sigma L1, it is the resistance of wire AP. E1 is equals to I sigma L1. This is the equation number 1. Now, without changing the current in the wire, means don't slide the rheostat. By keeping the position of the variable point of rheostat is fixed, means here we are going to maintain a same current. Now open the key K1 and close the key K2. Therefore the cell E2 comes in the circuit. See here, now without changing the current in the wire, open the key K1 and close the key K2. That is cell E2 is in this circuit. Find the balancing length of L2 for that cell. Balancing length L2 for that cell. And therefore we are able to write that E2 is equals to I sigma L2. This is the equation number 2. L2 is the balancing length for the another cell whose EMF is E2. Here E2 is equals to I sigma L2. This is the equation of EMF of second cell in terms of resistance per net length. By dividing equation 1 and 2, we got, by dividing equation 1 by 2, E1 divided by E2 is equals to I sigma L1 divided by I sigma L2. I sigma get cancelled. Therefore E1 upon E2 is equals to L1 divided by L2. If we know the L1 and L2, then the EMF of two cells are easily compared by using potentiometer. This is the use of potentiometer to compare the EMFs of two cells by separate cell method or individual method. The principle of potentiometer: when current flows through a wire, a uniform thickness and the same composition, the potential difference between 2 points is directly proportional to length of the wire between that 2 points. V is directly proportional to L, and therefore V is equals to KL, where K is the constant of proportionality called the potential gradient. If we plot a graph of potential versus length, then it becomes a straight line. Means from that graph it is clear that the potential difference across any 2 point is directly proportional to the distance between that 2 points on potentiometer wire. See, this is the experimental arrangement of comparison of EMF of two cells. This is the first one cell whose EMF is E1. This is the another cell whose EMF is E2. Here our aim is to compare the EMF of two cells. This is the driver cell. Here in this diagram is the experimental arrangement of comparison of EMF of two cells. This is the first one cell whose EMF is E1. This is another cell whose EMF is E2, whose EMF is to be compared. This is the driver cell. This is the rheostat, and this is the ammeter. Here this is the plug key. This is the jockey. This is the galvanometer. Okay, now we are going to close the main key K and K1 so that cell E1 comes into the circuit. And then after we starts to slide the jockey on potentiometer wire and we obtain the point P at which galvanometer shows zero deflection. This is the point J where the galvanometer shows zero deflection, and that the point is balanced point. Here the EMF of that first one cell is directly proportional to the balanced length on potentiometer wire. See here the balanced length. Suppose it is denoted by L1. Therefore E1 is directly proportional to L1. Now I am going to click on this key, as well as I am now going to open the key K1. Then after, now once again we are going to close the main key K. Then after we are going to close the key K2. Therefore cell E2 comes in the circuit. For that cell, by sliding the jockey on the potentiometer wire, we obtain the balanced length where the galvanometer shows zero deflection. Suppose that length is L2, therefore E2 is equal to K into L2. ही जी आहे ती एक्सपेरिमेंटल अरेंजमेंट आहे, फक्त तुम्हाला ती अंडरस्टँड व्हावी. हा मेन पर्पज. इथं रेशो दिलेला आहे E1/E2 इज इक्वल्स टू L1/L2.